Problem D. You might wonder why D is the same type of problem because it's the square root of a whole fraction, 10 over 3. But if you remember from earlier in this chapter, if you take the square root or root of an entire fraction, it means you have to take that root of the top and the root of the bottom. So I can break this up into the square root of 10 over the square root of 3. Then it's a little bit more clear as to what the issue is. I can't have a square root in the bottom and I've got a square root of 3. How do I get rid of it? I'm going to multiply the bottom by a square root of 3, but then I have to multiply the top by a square root of 3. So what does that get me? On the bottom, the square root of 3 times the square root of 3 will just give me 3. And on the top, let's see, we've got the square root of 10 times the square root of 3, which is the square root of 30. Now, there's nothing you can break down the 30 into that you can take the square root of, so it is reduced like this. Your final answer is the square root of 30 over 3. And again, we don't have a square root in the denominator, so we are good, and the 30 doesn't break down, so there really is nothing else I can do. Let's take a look at E. In E, again, it looks like we have a different type of problem, but remember, taking the root of an entire fraction means we're actually taking the square root of the top, square root of 24, and the square root of the x. So my problem is that I don't want to have a square root on the denominator. So how do I get rid of a square root of x? I'm going to multiply the bottom by a square root of x, but then I have to also do that to the top. So let's see what that does for me. On the bottom, a square root of x times a square root of x, the square roots will cancel out and leave you with just x. And on the top, the square root of 24 times the square root of x will give you the square root of 24x. Now, you're almost done. There is a slight issue with the number 24. Remember that 24 can be broken down into, let's see, 6 times 4. And why is this important? Because you can take the square root of 4. It comes out as a 2. However, you would still be stuck with the 6 inside of the root. So what this will do is this will give me 2 on the outside of my root, and the 6 will stay on the inside with the x, and I still have the x on the bottom. Okay. I know it's tempting. You want to cancel out the two x's because you see one on the top and one on the bottom, but you can't. One's inside the square root on top and one's outside. So think of that square root as a big barrier. You can't cross between them. So you can't cancel out those x's because one's inside and one's outside. So our final answer is as you see it, 2 square roots of 6x over x. And that's our final answer. F and G are pretty similar, so let's just do one of those two. Let's just go ahead and do G. So if we look at G, we've got 2 square roots of 5x over the square root of y cubed. So the special thing about y cubed here, taking its square root, is this can actually be simplified before you do anything. Because 2 does divide into 3, although it's not evenly, it does divide in. So as a reminder, 2, so we've got y to the 3 halves, so 2 divides into 3 once as 2 with a remainder of 1. So we'll have 1 of our y's coming out and 1 of our y's staying inside as a leftover remainder. So you'd have 1 y coming out and 1 y staying in. That is just reducing our root before we do anything. then my problem is not with the y that's outside of the root. My only problem is with the y that's inside of the root. So that's the only thing I'm going to focus on getting rid of. So how do I get rid of a square root of y? I multiply it by a square root of y. But if I do that to the bottom, I've got to do that to the top. So let's see what that does. Well, notice on the bottom, I have now a square root of y times the square root of y. The two square roots will cancel out, leaving you with a y, but you already had a y. So we've got two y's on the bottom now, which means I've actually got a y squared on the bottom. Okay, what do I have on top, though? Well, on top, let's see. I had a 2 on the outside. That'll stay outside. And on the inside, I have a 5x and a y. So I'll have that square root of 5xy. Notice, again, just like the last problem, I can't cancel out that y that's on top with any of the y's on the bottom because the y that's on top is inside of a square root. Meanwhile, the ones that are on the bottom are outside of a square root. So they can't be mixed and matched. Think of that square root as a big barrier you cannot cross. So our final answer is 2 square roots of 5xy over y squared.